Hello, this is Noah Johnson, candidate number 8417, and this is my computing project. I've made a trajectory simulation, and this is the objective rundown. So, objective number 1, create an effective tool which can be used by physics A-level students to model simple projectile motion. So, as you can see here, I can plot projectile motion using the program just fine. So, objective 2, create a tool which allows users to adjust the starting height, initial velocity, projected angle and starting position of the object. So, going back into my form, you can adjust any of these, do anything you like, and then you can press plot and it will plot that trajectory. Objective 3, the tool should use the SUVAT equations to calculate the outcome of a projectile. So, looking in the form here, you can see that I use SUVAT equations here to model the trajectory, which is also explained in the complex code appendix at the end of my project. So, objective number 4, the program should display a visual representation of the projectile. So, if you look back at my program, here's the visual representation. Objective 5, add the ability to view total time in the projectile system, as well as max height and final distance. So here we have it. Each time you plot projectile, you've got total time of flight, maximum height, maximum horizontal distance, each given to 3 decimal places. So, going back to here, energy must always be conserved in a closed system, meaning no energy is lost to outside forces such as air resistance. So air resistance is negligible in this situation, which you can see in the SUVAT equations used for this scenario. So objective number 7, allow the magnitude of gravity to be able to be changed so students can model projectile motions in systems with different gravity. So as you can see here in the program, there's a selection of pre-made gravities for each planet in our solar system, as well as Earth's moon. So you can fire a projectile using these gravities and it will show you the trajectory of that. Objective, and additionally you can edit it to be anything you want. So if you wanted something with a lot of gravity, it's not going to go as far, whereas you can have something with a lot less, and it would go a lot further. So, objective number 8, include help tips so as to aid the student in setting up their projectile. So if you press help, you bring up these tips here which explain, as it says in the objective, e.g. explaining what each parameter means in the context of the system. So back into here, all of these will explain what each of these parameters mean, as well as the 3 results that you get after in the launch info panel. So there's a help there. Objective number 9, allow the trajectory of multiple particles to be modelled on the same set of axes. So you can change any of these parameters to be anything you want. Model another projectile, and it will show the trajectory there, and you can also adjust just one of these parameters slightly, and it will show you the trajectory of that particle as well. So objective number 10, ensure each parameter is checked against certain criteria to ensure the system is always valid. For example, angle of projection must always be between 0 and 90 degrees. So if you look here, if I put the projected angle as larger than 90 degrees, we'll get an error message. These variables are invalid. Projected angle 100. Ensure all values are positive, real numbers, and angle is between 0 and 90. So if I set this angle back to be between 0 and 90 degrees, it will plot it. If I put it as a negative number, get an error message. And additionally, if there is a correct value but there's letters at the end or anywhere within thing, you will get another error message there. So I'll end with just showing the program running end to end. And there you have it. And you can plot tons of projectiles and they will all appear on the same set of axes. There they all are. So thank you for watching.